All right, welcome to the May edition of the monthly meetup for Leptos, the full stack Rust web framework. My name is Luke, and I'll be hosting again this month. I am super stoked for yet another awesome monthly meetup. We've got a great little program put together for you. As always, if you want to join our Discord server, link is in the show notes. You can head over there. We're having a little watch party over there going on, and we're also hanging out after the meetup in Discord. So this week we've got sorry, I've got to shut it off because it's getting an echo. So this week we've got three people. We got Greg, we have Maccesh, and we have Adeoye. I don't know, Adeoye, if I'm pronouncing your name correctly. I think this is becoming a recurring weekly theme at this point, is me getting struggling with people's names every week, so I'll do my best. But we'll go ahead and get it kicked off with Greg. We've got a super exciting code splitting demo. He's actually going to step in for Ben, who unfortunately wasn't able to make it this month. But Greg is going to do his best to give some updates on some proposals sent over to the Rust project. Maccesh is going to give an exciting new update on the Leptos-Struct-Tables, and Adeoye has done Leptos remix icon implementation, which is going to be super exciting. So I'll go ahead and bring Greg up on stage. And Greg, as you get started, I just want to remind the audience that if you have questions, please put them in the chat. At the end of each topic, speakers will take on questions. And yeah, they're happy to answer any questions you have. So Greg, I'll go ahead and pitch it over to you.
Hey, Luke. Hi, everybody. Welcome if you're here live or if you're watching later. Good to see you all. I was just saying to Luke, it feels like every month we come up to this meetup now, and I'm like, oh my gosh, I can't believe it's been a month already. So it's been a busy spring with a lot of good stuff going on. Yeah, so I mean, Ben was going to share an update that I'll kind of share on his behalf as much as I know. But you may have noticed he's been kind of buzzing around at different conferences. He was at Rust Nation UK. He was at Rust NL in the Netherlands, or he was at the, there's another conference that's happens at the same time. And then there was an Unconference connected to Rust NL. So he gave a talk at the other conference, and then he was talking with people at the Unconference for the Rust stuff. And I know he just did another online, like a talk at a meetup that I think was in somewhere in West Africa, maybe in Nigeria. And he did that remotely. Yeah. So I'll just say before getting into other stuff, right? You know, this isn't like a startup or a business. There's no in-group and out-group. If anybody wants to get involved in giving talks at your local, Rust meetup or various Rust conferences, and if you're wondering how to kind of get started with that, feel free to let me know or let Ben know. He's given a bunch of these talks. It's mostly just scheduling wise that I haven't, but it's been awesome to see him out there and bringing people, kind of bringing Leptos to the community and the rest of the Rust community to Leptos. And I know folks from the Rust project and the foundation have been really supportive of that, in part because we are the sort of one of the main community-driven, non-commercial, non-business type web frameworks. So people have been really supportive of that. So yeah, if you're interested in giving talks at your local meetup or getting into stuff in a conference, there's no like permission needed. We're happy to offer any help or support that you want. So yeah, out of that Unconference part, there was a kind of meeting between, I know that at least folks from the Dioxys team, some folks from Xylem, which is more of a native Rust UI, but really exciting framework and really cool work they're doing. And then I think some folks from like the Rust project or from portions of the project. And Ben, after his talk, they kind of got together for a couple of days and they were having a conversation about, what things from the Rust language and ecosystem would be helpful for UI libraries. And it was kind of, I think, a big picture, like beginning of a conversation, right? So I don't want to list anything off that people are talking about as if it's around the corner. But, some of the things that I know folks are talking about were things like things that are useful to me working on the library, like, oh, can we be generic over tuples of any length, right? Stuff that we currently have to do with macros. And then there were some things like, talking about proposals for easier cloning things into closures, which is where a lot of the like stuff that we do around making signals copyable, because you don't want to have to explicitly clone them everywhere, like you'd clone an RC or something just to put it into an event callback. So conversations about like how they can make that easier at a language level. And then other conversations. I know Jonathan Kelly from Dioxys has been kind of pushing on some of these questions people have been talking about recently about things like faster avenues in the compiler to make the kind of iteration speed faster. And I know, I mean, they're working full time on Dioxys now, and he's been pretty interested in pushing some of that forward to make UI development easier with Rust. So all of that is just to say, I mean, there's probably a lot more detail, and I wasn't there for any of it, but that's kind of what I heard from Ben and from others. It's a really exciting time. I guess it's just a sign that people in the Rust world are starting to kind of coalesce around the idea of getting serious about making it easier to do some UI development and web development with Rust. So yeah, it was pretty exciting, and I think that there will be more fruit that comes out of that. So far, it's just like the very beginning of that process. So that's most of what I have to share from Ben's stuff. And if you haven't watched either of his talks, I think that they're both on YouTube now, both the Rust Nation and the recent one, and we can drop links in Discord if people need help finding them. But they were really good talks. So I hope more people can get involved in doing stuff like that. I've been spending a lot of time this spring, in addition to just having like a busy spring with my work life, which is not Leptos. And personally, I've been kind of cracking away at moving towards 0.7. We do have a preview release out. There's, a branch on GitHub that I'm pushing commits to a couple times a day. I would expect something like an alpha, in the next week or so. I'm trying to kind of get things into a working state for every preview release and then maybe breaking them in between. And I'm just slowly working through the examples and stuff and making sure that most of the patterns that you can currently use are still working. So it's been kind of slow work. I've been doing that for a while, and then we'll be updating docs and things. One of the things that has slowed me down a little bit. Oh, and I guess I'll just say for anyone who's curious, right? People ask like, oh, when? I would hope to have like a really solid beta release that people can really start using out by, say, the end of June, right? To have it really in testing mode and then, release sometime a little later in the summer for a real 0.7. But even right now, it's usable for experimenting and building basic stuff. I wouldn't go in and try to kind of convert your whole app all at once because there are a number of things and there's not like a migration guide or anything. But check out the preview channel on the Discord if you're interested in kind of sending feedback back to me and stuff. It's been really helpful to me to have people experimenting, building stuff, and then reporting back all the little things that are broken. And we have some people who have been doing that, which is just great for me to realize what on the list hasn't happened. This release is basically a rewrite of most of the internals of everything. And so there are lots of things that are just not quite re-implemented the new way yet. But we're trying to keep the application code that you would write as similar as possible, which is part of why it just takes a while. Like releasing a version that's hard for you to migrate to is easy. Releasing a version that's easy to migrate to is hard. But one of the things that's kind of slowed me down in a good way a little bit recently is some of this work that I've been doing about code splitting. And that's what I'm going to kind of spend the rest of my time here talking about. I had been expecting to be doing this more 6 months to a year from now, but there was somebody who was actually working on it. And so I kind of jumped on it because we want to be able to be ready for it in what we're doing right now. And it's one of those things that's probably easier to start showing you than just to tell you about. But at a basic level, right, one of the big issues with WebAssembly as a target for compiling applications for the web has been that so far, all you can get is WebAssembly in one big blob, whereas in the JavaScript world, that can be split into a bunch of smaller JavaScript modules, which means, when you first load a page and you have a Leptos app currently, you need to load the WebAssembly blob for the entire application before you can start interacting with anything. And that can be slow, whereas with a JavaScript application, you just need to load that one entry point, and then it can load the rest of it on demand. So I'll start sharing my screen now and just showing you the difference between what a current app is, right, and what we're moving toward. Beautiful. Okay, and I hope this text is big enough for people. I tried to make it pretty big. But so here's a basic application. This is in 0.7, and this is just the main function, and we're gonna mount something, and we've got a nav here with some links to pages A, B, and C. And then we've got a router. We've got the routes. There's route A, there's route B, There's route C, which is the nested route. And this stuff, we'll talk about that later. But if I open up this page, I click it, and you'll notice I slowed this down to be fast 3G. If it's on localhost and it's regular unthrottled, you're not even going to see anything happen, right? So I refresh the page. It starts loading in the localhost HTML. Once it gets that response, it starts loading the JavaScript and the WebAssembly. And then once it's loaded all of that, it can start running. And this is just client-side rendering, by the way. There's no server-side rendering here. So if I click on page B now, it's just going to load some data for page B. It's going to load these comments and then render it. And if you, oh no, my video is giving a random thumbs up. Thank you, macOS. Okay. And if you go down to this view B, right, it's pretty straightforward. This async drive, think of it as being like a resource. So we're just going to, we're creating some thing where we make a fetch request, and then we read it under suspense and we render it. And if you're curious about this async suspense stuff, see one of our past meetups. You can use actual async in suspense in the future. So this is fine, right? But if we go back here, when I'm on this page, I have to load this whole 286 kilobytes. But then when I navigate, I only have to load this blob. And that's not bad. The problem is that as the application scales up, those 286 kilobytes become bigger and bigger and bigger. So obviously we want to find some ways that we can make the initial loading time, the initial interaction, a little faster. So somebody who is not me, right? Somebody just out in the Rust WASM ecosystem did some work to allow you to basically create a CLI tool to actually allow you to split this one big bundle into multiple binaries. So we saw our sort of baseline. This is the way that it works right now. And what's the next step? So we might think, okay, let's split this view so that we can lazy load that second route. So we have like a main bundle for the main page we land on, and then we're going to load B when we need to load B. So this is the work that they've basically done. So I'm gonna change this a little bit. We're going to create struct view B, and then we're going to implement this trait for view B. And this is a lazy route, and it's just generic over the rendering type. This API isn't worked out. This is just a demonstration of the technology. And this has two methods in this trait. One is data, which returns the struct that we're working with, and the other one is the view. So for now, let's just start with this as it is. And you'll notice Rust Analyzer gets a little bit confused by async functions in traits. So all of this stuff is the same, as just making this an async function view. All right, and then if we go up into our route definition, this is just going to change to be lazy view B new. Okay, and some of these things, are slightly awkward APIs, but it's kind of like not the end of the world. These things will be smoothed out. And this needs to be a clone. Great. Okay. So now I've made it my lazy view. I'm going to build it again. Great. And now we're going to load it here, right? And you see, what do we have? We had, okay, good. We haven't actually made anything lazy yet. Sorry. So this works the exact same way. So we still load 289 kilobytes. And then when we clicked, we loaded the comments, this data here. So we made it lazy, but it's not actually lazy loading anything because we haven't marked it to do that. This part, right, for this async function view, this is where we do get into stuff that is slightly hairy. And so I'm going to copy and paste for the sake of sparing all of us the compiler errors because we've got a little ways to go. This is the sort of thing that is a bunch of boilerplate that we will just improve with a macro. Basically, it has to do with things like type erasure and the way this code splitting tool works. It's not that interesting. but I've just created an inner function here. And you see there's this WASM split. And so we're going to split out this viewB function and build it again. Okay. So now when I load view A, it only loads 238 kilobytes initially, not 289. And then when I click view B, it's going to, you see it loads like 40 kilobytes here. It has a couple of other little split out children. And it's probably hard to see on the stream. They changed how this works in Chrome, and I'm not sure how to zoom in on these little bars anymore. You can see it's actually loading 3 different WebAssembly files concurrently. And then after it loads those, it starts loading the comments. So this is pretty good. This is an improvement, right? We shrank the initial binary size, which means we broke that link between the size of the app and the size of the initial load time. In other words, like we made it so you can enter and you only need what you have on that page. And then when you navigate to a new page, it lazily loads the WebAssembly binary for that component and for that data that we loaded in the component. And then when that's done, it's able to render. But you notice that there's actually a kind of a big con here, which is that it actually slowed down the navigation to page B, because previously all we had to do to go to page B was to load these comments. And this is a pretty big JSON file. It's like 40 kilobytes. And so it takes a little while on a slow connection like this, but that was all we had to do. Now we first have to load the WebAssembly for page B. And then because the fact that we need to fetch is inside the thing that we lazily split, right? So like here's the view function that we split out lazily. So it's not until this lazy loaded component says, okay, you loaded me, I was lazy, but now I'm done loading. Oh, by the way, you need to go make this fetch request, right? So we want to ideally break out of that pattern where, you know, it's something people call a waterfall, right? Where like it loads one thing that then causes you to load another thing. And we want to make those concurrent if we can. And we can. So that's kind of level 1. Level 2, we're going to hoist the data loading out into a little higher level. So if you see this lazy route trait, right? And I didn't really explain this at all before. Your routes can be, the view can be just like it currently is, a function that just returns some view, like a component, right? So the stuff that you currently have will work exactly the same. But then we also allow you to create this lazy route trait and pass in some lazy route into the route definition. And so if you want to do just a plain non-code split synchronous route like you currently can, you can do that. If you want to make it lazy loading, you have to implement these 2 methods. And the point of this is you want to separate out the data loading part from the view so that you can start the data loading concurrently with lazy loading the view and run those concurrently. And then when the data is ready and the lazy loaded view is ready, you can render it. So what that means for us is just that, you know, view B isn't going to be an empty struct. It's going to be, it's going to have data, which is here async derived. I think this is a vec of comments. And then, you know, we're going to delete this local variable where we create that. Instead, we're going to move it up into our data function. And then here, instead of referring to the local variable data, which doesn't exist anymore, I passed it in as this. And so we're going to have this dot data, and we're going to await that. And so if we rebuild over here, then we can see this is the second version. So our idea here was to basically hoist the data loading out of the lazy loaded part so that we could do the data loading in parallel with it. And the router is actually set up to do this, right? The router has always been set up to do this, but we haven't had the code splitting ability. So now the router is set up to do it, and soon we will. We have an experimental form of the code splitting. So let me just clear all this stuff. So now you see localhost main bg.wasm, and then when we click B, it's going to, you can see it right here. So the gray bar here, which is probably pretty faint for you, apologies, but is the comments. and it's fetching those concurrently with fetching these 3 WASM chunks that are going into the view. So now we've got lazy loading the view, and we've got, whoa, get out of there. We're lazy loading the view, and at the same time, we're loading the comments. And so we no longer have that double wait, that waterfall where we waited for the WASM to load and then waited for the comments to load. But instead, we can load them in parallel. And the cool thing here that you might notice is actually you stop paying the cost of the next navigation. In other words, rather than waiting for the lazy loading and then waiting for the data, the sizes on this example happen to work out such that the time that's spent lazy loading the view actually fits within the time that you spend loading the data. So you get a benefit in that the initial binary is smaller. It's like 20 kilobytes smaller than it was. And then you don't pay any time cost on the next click because it takes longer to load the JSON than it actually takes to lazy load those views. And of course, that will all just totally depend on the data you're loading, the size of the views, all of that. This is just in one example, right? But you notice that actually what happens is that some of it gets moved back into this main BG. Like this is smaller than the first example where nothing was lazy loaded, but larger than the second example where the whole thing was lazy loaded. And it's because we've now taken all of the code to fetch and deserialize that data, and we've moved that out into its own, back into the main bundle. Like that's no longer being lazy loaded. And if you've worked with this stuff for a while, or you've heard me say, like, what are the things that drive binary size? Things like Sirdi are one of the big causes because they just tend to be relatively large in terms of binary size. So you notice if you think about it, like this is all pretty explicit. So the stuff that's explicitly marked as being lazy in here is being lazily loaded. And then the things that are in the data are not being lazy loaded. And the reason, again, for that is that you want the router to be able to start calling that data function immediately. So this actually can't even be lazy, which is one of the nice ways that the trait let us enforce that. Like marking something lazy makes it async, and this is a synchronous function. So you can call lazy functions, but the data function itself can't be lazy. But you can call lazy functions, I said. So this deserialized comments, I just said this takes a bunch of binary size because it's using Sirdi JSON. And if we go to it, we can actually take this super simple function, but again, like deserializing JSON is not that simple. And we can actually make this lazy too. So we can lazy load the deserialization code and try to push that back out of our main binary. And on these, compile times, by the way, it is running a separate tool to do this splitting. It's not that bad, really. That was a release build, so for a small application like this, whatever. But it doesn't hurt the compile times that much. All right, so we're loading again. We've got our main file. Now main BG is down to 247, so that's 22 smaller than it was before we lazy split the deserialization back out. And now if I navigate to B, what's it going to do? Interesting. So we ended up with another waterfall, right? Like if you look at this diagram here, and maybe I'll do it again a little quicker and not be chatting so much. Yep, cool. So you can see it here because it's a little bit bigger. So we see these same WebAssembly chunks where we're loading a bunch of stuff when we navigate. And we're also got this gray chunk, which is the fetch request for the JSON. And then after that, we've got another chunk loading down here. Well, this chunk is deserialized comments. Is deserialized comments, right? Loading right here. Because if you look at the way that I structured it, these things really are lazy. It's not just that they're code split, but they are then loaded lazily, which is kind of the point. But in a funny way, it does the whole request. It awaits all of that. And then it calls the lazy deserialized comments for the first time. So it doesn't actually start loading the comments deserialization code until after the comments are all the way loaded. So this is the part where my response is like, this is becoming awkward. And there are really silly ways that we can get around that. So, it does become awkward. So let's say we create a second, like a pretend piece of data that we load. And let's see, we're just going to deserialize comments from like a fake empty string, right? And we're going to put a comma. We're going to put another comma. Beautiful. And I think that's just warning me that it's an unnecessary. Nope. Oh. There we go. And so what I did there, oh, and I may need to actually use it. It might be too smart for me. Good, yay! We got it all loading concurrently, right? So what I did there, for anyone who was watching and not quite following, these async derived things, that's like a resource. When you create them, they start loading the data because we want to start loading the async data as soon as we can. Which means that this one, when we create it, when we start navigating to the page, it creates one thing that just tries to deserialize a comment, which means it starts loading the code split lazy loaded deserialization code. And then the other one is making an actual request and then deserializing actual data. But it means that one of them is asking us to already start loading the deserialized comment code, which means we end up with this beautiful moment where on the navigation, we're on this is all the initial page. And then over here, when we click that button, it's loading 5 separate lazy loaded WebAssembly binaries concurrently with the data, still in a way that all of our WebAssembly is done coming in before the JSON is finished, and then it can render all of it. So like we've successfully achieved our goal there of going from 289 kilobytes of WebAssembly, I think, down to 251 in the main bundle. So we've successfully split out that whole route, made the initial load time faster, and then we're not paying any cost on the next navigation because everything is loading concurrently. I hope that there are questions because that's a lot. I'll have one more thing that I'll show you that's just another advantage. One of the reasons that we use, so people start sending questions if you haven't already, so that I can answer them. And I'll say the one.
Yeah, we do have a few questions whenever you're
beautiful.
finished.
Okay, good. So I'll just say this and then get to those. In this, you see this one has a parent route and a child route, the classic kind of nested routing setup. One of the reasons for nested routing is in a fine-grained reactive framework like this, no VDOM, right? We want you to be able to navigate between child routes and not have to do any rendering in the parent route. So obviously you want some kind of structure there, and that's what we have with nested routing. That's like the explanation I've always given. The other advantage is that when you have nested routing, it means you can define that data loading separately for each of those nested routes. So if you have 2 nested routes, say one of them is a list of posts, and then the other one is a list of comments on a particular post, whatever it is. When you navigate to the blog page from the About page, one of your routes can be fetching all the posts, and one of them can be fetching a particular post with all its comments. And when you have data loading like this that's separate, each of those can be loaded lazily, the component to actually show the view, and then each of their data can also be loaded lazily, and all of those things can be done concurrently. So I'll just show you the navigation to view C, which we haven't really looked at. View C has this child, which is confusingly named view B child because I changed the order of the things. But view C is just another one of these lazy routes with some data that it's fetching from some API, and then a view. And in its view, it also has an outlet because that has a child, which is the child. And the child is another lazy route, which also fetches some different data from an API, and then also just renders its data, right? So it's basically, if we had that view B that we were looking at, we took one and we nested it inside another, but they're fetching different data. So when we go to that view, just starting on the main one again, And then when I click over to C, you can see a bunch of stuff over here, and I'll do it one more time again, just for the size of the window here. Good. And you'll notice, by the way, that when you do that click, like it will wait to load everything and then navigate over, and you can do a kind of routing progress bar and stuff. It's all set up for that, but to prevent the sort of like splash of 100 different spinners. Okay, so here's right A, the main view. And then when we click over to C, you see all this stuff loading concurrently. We're loading the albums data for one page, the to-dos data for the other page, and then 1, 2, 3, 4, 5, 6, 7 separate WebAssembly binaries. And the code splitting tool here is actually kind of cool because it looks for shared dependencies and splits those out into smaller modules, so that whichever path you take, like if I now navigate to B, it only has to load actually the deserialization code and then the view B specifically. But there's a bunch of other little short shared bundles, view B VC, view C child, these things that are shared across the different views that it doesn't have to load again. So it's smart. It's smarter than just splitting out route by route. But point being, when I did that navigation to C, it not only can kind of parallelize that loading for one route, but it can actually do it for two routes, for the route and the child at the same time. So it's like, however deep you nest this, pulling things out into those data functions lets the router load the data and lazily load the views, even with the nested routing setup. So yeah, okay, now I will go to questions and let
no worries.
Pour in.
Okay, so yeah, moving on to some questions in no particular order. First, I'll hit the questions from Discord, from our Discord community. And by the way, if you're joining on YouTube, feel free to check out the show notes and head on over to Discord, where we're having a watch party. We'll be hanging out afterwards. So first question is, hello, I was mostly interested in the work that has been done with bundle splitting. How's it gone? And are there any blockers right now that need to be resolved?
Yeah, and I should be clear that this is not primarily my work. The application of it that you see here is my work. The actual work on the bundle splitting itself has been done, just came out of the blue base, basically, from my perspective. It's just somebody who's active in elsewhere in the Rust community. I can maybe I will drop a link to the GitHub issue into. I'm just going to stick it in StreamYard and somebody share it for me somewhere.
Yeah, I'll put it in the chat.
This has been done externally, right? And it's kind of out of my wheelhouse. So if there's anybody who is like familiar with the WebAssembly format or with this kind of work, or even just wants to look at it, it's not a super complex project. I just haven't taken the time to really wrap my head around it. So I think helping them improve and refine what they're doing and experimenting with it and stuff would be awesome, because it really is work somebody else has done. They opened it as a, would you like this as a PR to WASM BindGen? The WASM BindGen kind of team said no, because we don't want to take on the maintenance cost. It'll probably exist as a separate tool. It's something that like we would probably build into Cargo Leptos, and then you could just use the macros like this to annotate something. Like I'm picturing a single, that all of this stuff would just be like a single, lazy macro. And it just generates the rest of this kind of boilerplate for you. But I've just been seeing, like, technically, can we make this work with the router, pretending that we don't care how awkward the API is, and then we'll build the rest on top of it. It's something, it might not be released in 0.7.0 when it comes out, but I want to design the router to work with this so that like the code splitting stuff can be released in like a 0.7.2 along with an update to Cargo Leptos or something that builds in the code splitting. But yeah, it's I would encourage people to take a look at it. I've only bumped into a couple small bugs along the way. It's fairly robust and it works pretty well.
Awesome. I'm unsure if these have to do much with code splitting, but I'll put them up anyways for now. We do have some more code splitting questions though. But so can 0.7 do streaming stuff without WASM, such as log streaming?
It probably depends on what they mean. 0.0 can do streaming stuff without WASM. We have always had streaming server rendering, like HTML rendering, in the sense that you can have a streaming response from the server. That's like what suspense is by default. Then is a streaming response that streams in chunks, and that works with a very small amount of inline JavaScript, no WebAssembly, and that all works before WebAssembly or on devices without WebAssembly, which is a big priority for me. If they want to give more details on what kind of streaming they're talking about, that also is fine. But yeah, I mean, anything that's like application code you're writing in Rust needs WebAssembly, but there's a lot that the platform and the device can do. And when I say application code you're writing in Rust, right, like that's not really true. But if somebody means something like server sent events, like, yes, you can set it up without WebAssembly using JavaScript. But if anything that you're writing in Rust that's going to be interactivity on the client requires WebAssembly.
Awesome. Thank you.
Yep.
So moving on. Yeah, and I was getting thumbs up that you got that one answered. So moving on, can we use signals with event stream instead of static variables?
Oh, yeah, sure. I mean, I think a couple people have created different libraries over time to do like a server signal concept where you are able to update stuff on the server and have it sending through server sent events or through a WebSocket or something. I honestly haven't worked on any of those things that much, so others might know more than I do. And they're not tools that I particularly use in the other stuff that I work on. But yeah, it's definitely possible. And I'll say 0.7, the reactive system is designed less to be like primarily just working in the browser, so single thread and everything, and more to be a general Rust reactive system. So you can do things like keeping a signal, sending it across to another thread, spawning a new process, all of this in kind of the native layer. So it should be even easier to do that with the new release, I would say.
Awesome. All right, now some questions from YouTube chat. So, so this person asks, does this mean we could create web apps with third-party plugins and extensions this way? And they actually continue on. I'm thinking of plugins that can be enabled, disabled, and installed like WordPress.
So you're saying, as in WebAssembly plugins that somebody else builds that's, provided that then can be loaded in, linked in. Yeah, very possibly. I mean, it seems like to me, there are kind of two halves of this code splitting technology they've been working on. And one half is lazy loading some WebAssembly binary and running it from another one. And the other half is like the actual code splitting in your application. So like the code splitting and the lazy loading halves of it, in theory, are kind of independent. So the fact that the lazy loading part of it works pretty well does suggest that lazy loading things that aren't part of your application originally might be possible. And I guess, in theory, that's something you can do already. I don't know that much about it. But basically, as long as you're willing to call out through some shared API, whether that's through JavaScript or something else, you can load that already. You can load a WebAssembly module is just a module. So you can load a module already and call out to it. I guess it's sort of the same idea. So yeah, that should be possible.
All right. So moving on, Hagbard Celine is asking, splitting in Wasm-Bindgen was rejected and it's tried to get into Wasm-Pack. And I feel like the excitement has died down a little bit. Is there anything we as a community can do to help there?
Yeah, maybe not. I mean, I think that it's interesting, right? One of the reasons that was given for no, I don't think we want this in Wasm-Bindgen was it works so well as an external tool. Like the fact that you can implement it outside Wasm-Bindgen without actually modifying Wasm-Bindgen suggested to the Wasm-Bindgen folks, good, that should stay outside of it. And as a maintainer, I'm totally sympathetic to that, right? Like maintaining code that somebody else wrote that's big, that doesn't need to be in the library. That's always kind of a tricky conversation. So I can totally appreciate why they would do it that way. But if the person who developed it like wants to publish it as a crate, and then we can depend on that crate in Cargo Leptos, like we can just use it, right? We have our own tools other than Wasm-Pack. And certainly getting it into Wasm-Pack would be another thing because there are probably people who use that, or just having it as its own separate tool. So I don't really know the answer. It's not something. Don't go on the issue and put in 100 replies saying no, we want this in WAS and BindGen. That's not the way to do it. But certainly, having somebody who's interested in exploring how to integrate it into Cargo Leptos, right? Like making a PR to bring that WASM split CLI code into our own tool. I think that would be awesome. So if people want to help, I think that's the place to help, is seeing it's open source, right? Seeing how we can take this person's work and integrate it with our work. That's what I would say.
Cool. That's awesome. Yeah, and that makes a lot of sense. Regarding not wanting to bring it into BindGen if you don't need to.
Mm-hmm.
Yeah, that makes a lot of sense. So Lucas asks, how large is the overhead per WASM chunk? Like the startup cost per chunk, I guess.
Yeah, that's a great question. I don't know that I know the answer. We can experiment around a little and see. I mean, I guess here would be a good way to do that experiment. If we clear this and we start on page A, and then we navigate to page B, we get a total of 384 kilobytes. And I guess if we go in and I'm just going to hold down the U key and try to undo everything I've done since I opened this. It basically, if we just compare it to there we go, the version where we didn't split anything out. So somebody remember this number. It's 384 kilobytes. Did I do this? I think I did this. Cool. Yeah, okay. So the version with no code splitting was 372 kilobytes. The version with code splitting was 384 kilobytes. So in terms of the overall, you loaded 12 kilobytes additional of WebAssembly, right? Because there's like some glue code involved there. And whether that was how much of it was WebAssembly, how much of it was JavaScript, whatever. But, so that was 12 kilobytes total overhead in exchange for about if I can do math, 40 kilobyte reduction on the initial load. And like I showed, with this particular data, there wasn't any time cost to the additional loading. I mean, I guess if you're super bandwidth constrained, maybe it splits between the different files, and so it takes longer. I don't know, but I mean, ultimately, I think this is something that is, as you can see, right? Like we'll provide a little bit more of some tooling around it, but it really is up to you to insert those. Here's what I want to lazy load. Here's how I want to do it, so that you can control where you're splitting something out and whether that cost makes sense. I mean, I think the broader point is basically it's less about 12 kilobytes here or there, and it's more about, can you break the linear relationship between the complexity of the application and the size of the initial binary? Because once you can break that relationship, right now, the more of an application you have, the longer it takes to become interactive on any page. If you can break that linear relationship so that there's a constant chunk for that first page, that is what allows you to just build larger and larger applications, or to do things like, oh, well, I have a blog, but the admin page is getting compiled into the page to load a post, right? Like breaking those things apart, even a single lazy there could be like, oh, I just removed 75% of the binary size for everyone except me, right? Like that stuff is big. So there is definitely a small overhead, and there's definitely overhead in calling out through JavaScript to do stuff, right? So this isn't the fastest way to run the WebAssembly code, but it's the fastest holistically, in the sense of like performance on the web is so much about load times, and then time to interactive and interaction to the next paint, right? And being able to tuck these things inside one another concurrently helps with all of that.
Awesome. Rakshit, it looks like you're talking, but you're muted.
Yeah.
Did you have something to add?
I was on mute. I didn't realize. Greg, I just wanted to add something to that.
Yeah.
So there are two ways of looking at this. One is the overload that it takes in terms of size, and the overload that it takes in terms of runtime, right? And like you mentioned, the size overload is definitely worth it, because you're going to be taking out all the common things across multiple pages, because let's say you have a top nav, right? That's going to be there across all pages no matter where you go, and that should probably be separated out and loaded once, and that's it, right? uh, but on the other hand, things like the actual content you show, that should be into separate bundles. So it makes perfect sense over there. But as far as code splitting in terms of runtime overhead, there is virtually zero, is what I would say. Because this was a blog I read about Mozilla on their browsers and rendering engine. They basically said that JavaScript requires the whole thing to come through, and then they start interpreting it and then warm up the engine and then execute it, right? In the case of WebAssembly, they're able to run the code just as fast as it's streaming it,
Yeah.
right? So you don't even have to wait for the entire code base to load for you to start running it. So
Yeah.
as soon as the first byte comes through, you've started executing the WASM. Yeah.
Right.
So that I think is a huge advantage especially with code splitting, because we don't have to worry about runtime overheads at all over here.
Yeah. Totally. And I mean, even with the load times, right? Like you've seen, there's a reason that I'm running all of this on slowed down to fast 3G and with cache disabled, because like if I just run it like I normally would be on my net, like that was the initial load. Like I couldn't even see it, right? So I mean, all of this stuff is about optimizing for the slower cases, the lower end devices, places with slower connection, sitting on a train, right? Whatever it is. And compared to the cost of, people ask about like the runtime cost of, does it make running a function slower? And like, yeah, maybe it might make running a function slower. I haven't measured, but that's why we're putting it at things like route navigations, right? Things with a user interaction that's loading data that you're expecting it to run. You don't put this at, you're like, this is my super performance critical thing, and I'm going to split out 10 pieces of it while it's running. You put it at these natural breakpoints anyway.
All right. Awesome. All right. Then are we ready to move on to the next question?
Yeah.
Okay, cool.
Yeah, and that's all I
let's
had to add
see.
from my end. Luke, you can pull me down. Yeah.
Okay. Thanks, Rush. Thanks, Rush. Yep. All right. So we got another question from Hagbard Celine. What is the plan and how opaque versus how detailed I can control the splitting? Because it looks very powerful. I can see having defaults like every route and more detailed control.
Totally. I mean, you could kind of see me playing with it. I know that was like a lot coming fast, but the difference between this function, this one function that was just this one line of deserialization, being a regular function versus being lazy. And again, like if your brain starts fuzzing out, right? Imagine that this is the syntax, right? All it does is it takes a function and then it makes it an async function instead. And like some of the rough edges, I don't think it currently actually works with things that are already, some things that are already async functions. There have been some like it's not a perfectly polished tool yet, right? But you can do it on any function. It's just a question of, what I would say is you want to actually run through those scenarios then and see the effect that it's having. Because like we saw what happened when I just made this one lazy without kind of eagerly loading it. Like it just created another waterfall where once the data had come in, then it started loading the deserialization code. So you want to actually look at what it's doing. You don't want to just add an infinite number of split points. And the tool itself, like I showed, I think now, of course, we've gotten rid of the actual lazy version, but you saw how it was loading like all 5 different modules to go to page B, not one module. So the tool itself will get very granular in how it splits things apart, because it looks for symbols in the WASM binary and it says, okay, if this symbol is used here and here, then it splits it out into a new module that these two will both load when they need to. And then the other one, when you navigate to it, it will already have loaded it. And it just loads all its dependencies at once. So it will get pretty granular in the splitting. And you can be as granular or as coarse-grained as you want with telling it where you want it to split. Like you tell it all the places you definitely want it to split, and then it will split the actual binary however it decides is most efficient, if that makes sense. So you could do these just on routes. You could do it just on some routes. You could do it on all routes and child routes, all routes and the data. I mean, you could think of all sorts of ways to do it. You'll have all the power to do that you want, I think.
Interesting. Awesome. Okay, cool. All right. Okay, so we've got the last question.
Awesome.
This is from Danix. And I think this is a pretty good question. I think it's a good question to end on. And it's probably a question that is going to be a little bit of a perennial question, I think people often ask, but
yeah.
What is the future vision with Leptos? I'm thinking to move the whole web dev to Leptos instead of React. Will it be a long-term supported web framework, or should we wait a bit for using it in production?
Yeah, I mean, great question. People ask this question all the time. I genuinely feel like in the kind of web dev scene in general, there's been a lot of 2023 was a year of a lot of innovation and new ideas and changes. 2024 has been relatively less exciting in terms of new stuff. And a lot of the patterns have kind of been landed on, in a sense, I think. I am feeling like this release is the sort of thing that we'd be ready to move toward 1.0 with. In other words, that like the paradigms and the way that the code is set up is the right approach. And, it's not ready for 1.0 yet. I would say it would need like at least 6 months, 12 months in people actually using it and making sure that's the right APIs, right? 1.0 is pretty big in like the Rust world. There's a certain assurance of stability there. But it's an open source project. It's entirely community. There's not a business behind it for better or for worse, right? So it's not a situation like so many of our web framework brethren, where they're some kind of a venture capital backed company that then gets bought up or sold out and then kind of slashed. So that's not going to happen to us. But it is entirely kind of volunteer and free time work. So this isn't React with 25 people working on it full time, spread across, Meta and Vercel, right? And so, long-term support to me implies like a certain kind of corporate responsibility to customers. That's not the situation. It's not something I plan on abandoning. It's something I feel like I've been kind of working on at a sustainable level for me, and that I kind of plan to keep working on. And there is also a time when things are done, right? We don't have to constantly be chasing the next thing, the next thing, the next thing. Sometimes a project has basically reached what it needs to be. And then we can keep on with maintenance, keep on building stuff. People can keep building new features on top. But, I don't anticipate, I think this will be the last time that people will have to really modify big portions of what they're doing that I foresee, right? Like I don't have plans for big breaking changes in the future. At the same time, it's pre 1.0 software. So I think you kind of have to make your own decisions about what works for you and what's most productive for you and what's most fun for you. We have a bunch of people using it in production now, like Rakshith, who is just on, is one of them. Alex in the Discord community, who's been on these videos before, is one of them. So if it's something that energizes you to like work with, that's great. I would never tell anyone like, no, you should use Rust and WebAssembly and you should use Leptos because it's better. But if what you want is to move your whole web dev stack to Rust, then I think Leptos is a great way of doing it. So I think that's my answer there.
Yeah, I think so too. And I mean, it's probably also worth mentioning. I think it was like last summer or something. There was no point in time, obviously, when there was like, okay, it is now production ready, but I think the kind of general consensus in the community, it was somewhere around like last August when people kind of felt as though it was comfortable to start running it in production. And I know Alex has been running it in production for many months already, since way back when. And yeah, Rakshith is running it in production. So there are people running it in production. There's probably people running it in production that we don't even know about.
Oh, totally. So, I mean, I will see things. I will see comments from people on, I think around like the 0.6 release, right? When we kind of rewrote the internals of all the server function stuff. And then you get like a comment on a PR being like, yeah, cool. We've got this in production on our 100 server functions that are serving like 10,000 requests, whatever. And you're like, whoa, okay. Didn't know the stuff I wrote was, actually, and I've never heard of the person before, right? And so people are definitely using it, right? I mean, not saying it's production ready doesn't mean, oh, we know that there are bugs and you shouldn't use this in production. It just is like, here's a high standard. I mean, if this was a JavaScript library, right, we would have had 1.0 18 months ago and we'd be on like 2.0 or 3.0. I just am more conservative about version numbers, I think.
Yeah, for sure. Yeah. And I mean, I've been kind of at least lurking in the Leptos community, I think, like, since really early on. I think like within 2 or 3 months of basically you pushing it out into the world, Greg. Like, I think within like 2 or 3 months, I was in the Discord server already, kind of just kind of watching, in the beginning, and like playing with it as well. But I mean, I can say that I've owned the growth trajectory of the community, and just kind of seeing people chat. It's just only gone up and to the right. So I think, and just seeing everyone's enthusiasm about it, I don't see Leptos going anywhere. I only see it growing, and I think it's got a very bright future. Just my personal opinion, and just kind of taking the temperature of the water. So
yeah, it's awesome. I feel the same way. And I think over the course of that time, right, it's been almost 2 years now. I mean, it was sitting on my computer 2 years ago for sure. And it's not like the paradigms have changed. Like, it's not like we've been flailing around trying to find the right approach. There have been changes around the edges of things, and maybe rewritten things may require some user code change. But like the basic paradigm is just the thing. We're not going to drop signals and pick up VDOM or something, right? It's just like, this is just what the library is. So in terms of the bigger picture of how stuff works, it's been pretty much set for a long time.
For sure. It's super exciting, man. All right. That was a great last question for you, Greg.
Great last question. Yeah, I was super excited about it. And thank you. Those are really good questions overall. Thanks to everyone for engaging. And I'm happy to answer any more questions on Discord or whatever about the code splitting demo or anything else. And looking forward to our other speakers today.
All right. Thanks so much, Greg. I'm going to go ahead and take you off. Maccesh, I'm going to bring you up. So before I bring Maccesh up, just a reminder to everybody, if you have questions, put them in the YouTube chat. We're also having a little Discord watch party, as we always do. So you can ask questions in Discord as well. Those get back channeled to me during the course of the meetup. And yeah, be sure to join our Discord. The link to join is in the show description. So Maccesh, I'll go ahead and bring you onto the stream. Adeoye, you are on deck after Maccesh. So now we have Maccesh up. He's going to discuss Leptos-Struct-Table. Maccesh is also the creator of Leptos-Use, which I know is one of the most popular libraries in the Leptos community. Kind of a little bit of a Leptos rock star in the community, if I do say so myself. So welcome, Maccesh.
Thanks. Yeah, nice to be here again. And before starting, I wanted to say I'm also using Leptos in production for, I don't know, half a year or so now, and it has been great. Sure, there are some changes that you have to work around, some bugs, right? Like, it's not 1.0, but it has worked well, and we haven't regretted using it.
That's great to hear.
Yeah, I wanted to start with Leptos-Use. There's a little bit of news, not too much. Let me share my screen. Okay. So there is one little new feature I wanted to show in Leptos-Use, and that relates to the single most common mistake people make when using Leptos-Use in conjunction with server-side rendering. What many do is, and it's understandable because this is the standard Rust way to do it, right? They add feature SSR just to the dependency like this. This is wrong, right? This is not the way to do it. The way to do it is, as with Leptos itself, you add it to your SSR feature like this, just as you do Leptos SSR, right? There are so many bug reports that could be that were resolved by just changing this. And now, to make it a little bit more obvious, there is now a warning. If you enable it like this, you will get a compiler warning telling you that you are using SSR together with WASM, the WASM target architecture, and that's probably not what you want. There are, of course, situations when you want that, if you use WASM on the server, and then you can enable the WASM SSR feature together with the SSR feature, and then that warning will be gone. So that's the only little news I wanted to share with Leptos-Use. Should I wait for some questions, or should I go on directly to leptos-struct-table?
You can, yeah, go ahead on the struct table. I'll keep an eye on questions, and yeah, go ahead.
Okay, very good. So leptos-struct-table has a nice bigger release that was done just today. And I wanted to quickly repeat what the leptos-struct-table is. You can have your struct, like this book struct here, and all you do is you derive table row, and you can specify some other options here, like sortable, for example. And what you get is then a table component. You can use it like this. You put it into a table tag and table content, and you put in the rows, which in this case is just a vec of these book structs, right? So that's nothing new. That's what leptos-struct-table is all about. What is new is now the default table cell renderer. So you have the option to customize the renderer with which these fields are rendered. But by default, if you don't tell it anything differently, it's going to use the default table cell renderer. And now this takes a bunch of options, but also the main thing is the value, right, which is the cell value that it's supposed to render, which is a maybe signal of t. And this t is now a cell value. It used to be into view, but so anything that was representable as a view would work, but now it's a cell value. And cell value is our own custom trait, which is this one, cell value. And it's very easy to implement. You just need to implement the render value function or method, which just renders it into something that is a view. And you have these render options that you can specify. And these render options, these render options, for example, for numbers, like for many default Rust values, this is already implemented, right here for all the number values. This trait is implemented, so it works out of the box, and all other kinds of standard library stuff. And for numbers, there is this number render option thing. And it has one field called precision. And you're now able to use that in your macro, like this, like here, right? This is such a number, F32. And in the format attribute, you can specify precision is 2, right? And that will then be taken by this number, by this implementation of cell value for number, right? Yeah, you can see it here like this. And the cell value was done by a contributor who did the work on that. And the cool thing about this is that now it's very easy to support third-party types. We already had support for Chrono, but it needed a lot of macro magic, which is now gone, because now for Chrono, right, we can simply implement the cell value for these chronotypes, for naive date, for example. And then here we have the render option, which takes the string, the format string, and then just uses it to call the format method of these chronotypes, right? So you can use it then like this, table format string, and this is the chrono format string, and that will render this state, right? And it just works. That allowed us to also add easily support for the time crate, which is the same thing. It also has the string and you can use it like this, right, with a format string, and this is now a format string of the time crate. Yeah, so that's that. Then there is a new sortable mode. So before, what you would do is you just add sortable to the crate, to the macro, and then if you do that, you can have this. This is the running example. You can let me reload this. You can sort, right, by title, but you can also sort by multiple columns. So now you sort first by author, then by title, and you can do this with as many columns as you want. But that's not what everybody wants. So now there's also a single column sorting mode. And the way you do that is the same thing. You add sortable to your macro, and then in the component where you use it, you have the sorting mode prop, and that you specify simply sorting mode single column, and this is the running example. And then if I click another column, it will just replace the sorting, right, which is a little bit easier to use, I guess. Yeah, that's it. There are a bunch of other changes and fixes. You can look at them in the changelog if you want, but these are the ones that I wanted to highlight. You're muted, Luke.
Thank you so much. I do not see any questions in chat so far. So I'll give everybody another second or two to ask any questions. But yeah, that's super interesting. Thank you for showing that. I always enjoy your updates every month.
Thank you.
While we're waiting for questions, okay, cool. Yeah, we've just got some positive feedback. What kind of a site are you running? Just to expand on this a little bit, what kind of a site are you running Leptos on in production? If you could kind of describe the application a little bit.
Yeah, it's a customer portal for a client. They want their clients to be able to log into their customer portal and then get some benefits depending on what partner level they have, to download some logos and images and get some press texts and things like that. Get the new thing that we implemented now is a calendar, an event calendar personalized to the customer. So it's, yeah, things like that. It's unfortunately not public.
Yeah, sure, no worries. Yeah, but yeah, that's super interesting. I thought that the person, I think it was Danix, who asked that, might be interested to know just an example. Okay, so I'm looking. I don't see any questions, so I think we'll just move on since we're already over 1 hour to the next speaker. So thank you so much, Maccesh.
Thank you.
I'll go ahead and take you off stream. Adeoye, I hope I'm pronouncing your name correctly. I'm about to bring you onto the stream. But before we go on, just again, a friendly reminder, go ahead and like the video. Liking the video helps us put it out into the world, get people more viewers, which always helps. Join the Discord server, the watch party at the link in the show notes. So Adeoye, I'm bringing you onto the stream, and it looks like you are muted. I'm hoping you are actually there. Are you there?
I'm here. Yes, I am. Can you hear me?
Okay, cool. Yeah. No worries. I didn't see your video, and I hadn't heard anything, and I was like, man, I hope I'm like actually bringing somebody into the stream. So,
I'm here.
All right, cool, man. So help me. How do I pronounce your name?
Adeoye.
Ade?
Oye.
Okay, dude. I was close, man. I have to say, every week I'm struggling with names, but I always get pretty close. If I have to give myself a little credit here, okay.
Yeah, that was a good one.
Yeah.
Thank you.
All right, cool, man. So tell us, you've got Leptos remix icons that you've implemented, right?
Yes, that's correct. So can I share my screen?
Yep. Go ahead and share it,
All
and then I'll put it up on the stream.
All right, great. Okay. So 1 minute, please. I'm on this.
Yeah, no worries. Take your time, man. Take your time.
Okay. So I've been building this tool 1 minute. Can you see my screen?
Yep.
All right,
the
great.
screen is up on the stream as well.
All right, great. So I've been building this tool for some time now. I call it its use. So my last workplace I had to have this readme, git ignore, and all of those. So I have to keep doing this over and over again. There's this template I ran into on GitHub. So I was like, how about I build a CLI that can just take away these routine tasks? So I built the its use CLI, but over time I need something I can use to store important information and be able to access them remotely. So I added a distributed storage to it. So over and over again, the project kept evolving. So at some point, I was like, oh, how about I build a, should I call it an home page for its use? That's where I have it on its use.search.sh. And that's where Leptos come in. So I've been a big fan of remix icon and material design icon. So I was like, oh, how about I already have the stack, the CLI, and the server written in Rust. So how about I just add a Rust web framework to that style? That also gives me the liberty of what I would do if I'm building it in JavaScript. So yeah, so I came up with this component to use the remix icon. It was pretty much easy. So how about I just revamp this into something I can push out to cargo, and I can always use it in other projects. So that's how I came about Leptos remix icon. So it's pretty much a tiny layer of a remix icon over here. So you have all the remix icon classes, and then pretty much that. So I don't know. I'm just gonna run through a quick demo if that works. What do you say?
Yeah, go for it.
All right.
Yep.
Good. 1 minute. Close this, and sorry, I have a few tabs open. Okay, so remember I have oops, it's supposed to be like post new, and then okay, so I have this template for Leptos Tailwind on my profile. I think I'm going to grab that. Yes, this one, and over here. So I'm going to call it RMI for Leptos Remix icon, and okay. So it's pretty much easy and straightforward. The first thing is to add the remix icon CDN here to the HTML file. Now, as of this time, I haven't explored the the server side rendered application, because what I built that led to me working on Leptos remix icon, it's a client side rendered application. This is the first time I'll be using Leptos just. So it's pretty much that. So I have the CDN right here into the HTML file, and this goes here, and then I need to add the library that will be the library exports a component, essentially a Leptos component called icon. So I need to import this into my application. That will be, this template is just an extract of the Tailwind example on the Leptos repository. So just like an extract of it. So it's pretty much something we're familiar with. So I'm going to drop that in here. Okay.
Hey,
then I come here.
Adeoye, would you mind turning off your
Yes.
video, because I think
All
the
right.
internet is a little laggy, and I think maybe if you turn off your video that might help.
All right, great. Thank you for that. I'm going to stop it. Is it better now?
Yeah, it's better now.
All
We
right,
missed
great.
about probably the last, like, I don't
All
know,
right, thank
30
you for the
seconds
feedback.
or so of what you said.
All right, great. So I was saying that okay, I stopped here. So I had the library. I did it already. So here I need to import the icon component. So the Leptos Remix icon, export this component, this icon component, and to use it, it's pretty much simple. All the classes I have on Remix icon can do, say, GitHub. So I have GitHub here. Okay, say GitHub Copilot. So I just need to grab the Copilot field without the RI, so we don't keep adding RI over and over again. So I'm just going to come in here. Okay, I'm going to delete the whole of this to make it a bit more readable. So I have and then I should probably okay, so okay, I'm just gonna give it some time to build. Now the other things I have, the other thing rather is I think yesterday or 2 days ago I shipped the support for the icon sizes. Now Remix icon has 10x, 2x. Yeah, so this is pretty much the icon that I added here. GitHub view. So I can do size. So size is 10x. Then this is build, and there you have it. So it's pretty much that. Add the link to the CDN into the HTML file, import the icon, then go to Remix icon. You can grab any of the icon classes without. Let me just do this. Okay, I'm going to duplicate this. Then I'm going to grab the class here. So I can do so I have this. So it's pretty much that. Yeah, that'll be all from my end. Thank you.
Awesome.
All right.
So
I'm
I'm looking for questions right here. Yeah. Sorry.
Okay.
Okay, cool. Yeah. So awesome. Well, thank you so much, man. That is super impressive. That is awesome. And I can say, having these kinds of, especially like the UI libraries, component libraries, icons, things like this, like having those built out for our ecosystem is super helpful. We do have one question from Alex. He asks, what is the icon component doing on the back end? Are these SVGs linked as an image to an SVG? Or the SVG code is an XML, XML, etc.?
All right. The Remix icon library. Let me go to the home page very quickly. They have 1 minute, please. So the Remix icon library, which the components, the Remix icon here, which the components tried to build a tiny layer of, is it exports a CSS file, and the CSS file contains all the should I say, I'm not exactly sure what to use to qualify it now, unless I need to inspect. So the CSS file here, remix icon.css over here contains all of those things, and that is what I'm loading over the CDN. I don't know if that answers the question.
Okay. Yeah, I'm not sure, Alex. I don't know if that answers your question, Alex, or not. If you wanted to ask something in the chat again, you could. Yeah, Greg also, and Greg actually, I think is kind of expressing the same sentiment. Yeah, Alex says yes, that answers it. Greg also expresses the same sentiment, I think, as I just did, which is that it's just great to have ecosystem libraries like this, which just make it a lot easier for people to build awesome things. So he says thanks for your work, and I'd like to echo that as well. So thank you. I do not at this time see any questions. So unless there's anything else, Adeoye, I will let you off the stream.
All right, great. Thanks.
All right. Thanks a lot, man. Okay. So thank you, everybody. That wraps it up for the May monthly meetup for Leptos. Thank you, everybody, for joining. As always, join us in Discord. In the show notes, you'll see a link to the Discord. Join us there. We hang out there. We ask more questions. We talk about all things tech. We've had some spirited discussions on ORMs in the past, as well as other frameworks. So join over there, hang out with us, have some fun. Otherwise, we're looking forward to seeing you at the next meetup. As always, it will be, normally we were doing it on Saturday. We experimented this month and moved it to Sunday. So I think next month we'll probably keep it on Sunday if we can. So for now, the last Sunday of every month at 3 p.m. ET. So we'll see you in June, or we'll see you in Discord between now and then. Take care.